Machine learning is a very powerful type of entity, but shall we always use it? How to decide the best use cases? These are some of the questions I will address in this episode. Let me start by asking a question. How much entity information can you spot in these sentences? It's easy to identify entities like the amounts paid and dates mentioned, but what made you recognize Rafting for Life or Sandy's Beach House as the name of a merchant? And how did you determine that bacon sandwich and wild water ride are expenses? These are all good catches, but how did you know? Have you ever encountered Sandy's Beach House or Mike's Parking City before? Chances are you haven't. These names don't follow a recognizable pattern and are not widely known. Yet, as humans, our brains and prior experiences aid us in determining the meaning behind these entities. But how can machines do the same? Our natural understanding of language allows us to infer from context. A conversational AI platform could use a list of values to hold merchant names, but can it hold every possible value? This is a good example where we are not able to know all the possible values, nor do those values follow any visible pattern. This makes traditional methods such as value lists and regular expressions not enough for resolving this issue, and it is exactly what makes the use case so tricky. Machine learning entities are the solution. Machine learning, or ML entities, are able to extract known and unknown values. They have a completely different mechanism than all the other entities. An ML entity is an entity type that is based on annotated utterances. These annotations show where entity values appear in the utterance. With the help of the training model created from these, entity values can be extracted from user input based on the wording of their utterance, even if the training data does not include those particular entity values. It extracts generalized values. There is a sweet spot when using ML entities, and it is not a solution for every use case. If we have a finite list of values, then the value list is the best approach. If the values follow a specific pattern, then a regular expression may be better. ML entities solve hard challenges but also require more effort to build a good training data set. They require a structured approach to designing and gathering data. First, we need to carefully identify which information in a message requires an ML entity. The name of a merchant in an expense report is a good example. Then we need to identify examples of how users would reference that merchant in utterances. This design exercise helps identify and narrow the exact use case for which we need to gather data. Then we need to gather that data in the form of utterances. There are many approaches to this, but that is the topic for another video. For now, suffice it to say that we need to gather paraphrased utterances. We need to annotate where in them the entity is present, and then validate that annotation. Once that is done, we have a working ML entity capable of extracting unknown data. Here, we have a skill that incorporates several intents and an ML entity designed to extract television show names. This is a great use case for ML entities as there is no way to know all the values in advance. The entity has been trained using annotated utterances, and in the current data set, there are approximately 500 annotated utterances. Each utterance has an annotation marking the exact location of the TV show's name. We can test the entity by searching for a show called The Orville and see that there is no match in the data set. However, when we test it with a test utterance like how many seasons does The Orville have, the entity is able to extract the correct value even though it was never trained with it. This showcases the power of ML entities. Now I'm going to try a different one. And again, the correct value was extracted. We also have a crowd data sourcing framework that allows us to gather data for the entity. Adding a new utterance to the data set is a simple process. We can filter the unannotated utterances, highlight the entity value, and then select the ML entity. With these steps, we can continue to improve the performance of the entity. And that is all it takes. ML entities allow us to solve a complex challenge, which is the extraction of unknown data. Check our assistant RT for more information. Links are available in the description.